So following on from the previous video, we got to this stage here where it really boils down to us trying to integrate this now from a to 9 of secant theta. So now it just boils down to us trying to integrate this, and we've already done this a long time ago. The way to integrate secant of theta is to realize that when you differentiate this thing here, it will be its exact same self times secant of theta. So to integrate this, remember, to integrate this, we need to realize that when you differentiate this, it will be itself times this thing here. So if you let this to be u, and this here to be u, then u prime here, that's u prime is this whole thing here, and this here will be u, and then secant here. So hang on. So you can say secant of x is this thing here. So if you're trying to integrate secant of x, you're really looking for something in such a way that when you differentiate it, it gives you this, or you're looking for something in such a way that will give you, when you differentiate it, it will give you this. Well, here, remember, when you integrate things, always keep an eye out on something being the exact derivative of another thing. Well, if whenever you see something being the exact derivative of another thing, then you can jump to natural log of this thing here. So if I were to give you this thing here, natural log of this bubble, if I were to ask you to differentiate this, you would do this, differentiate it. You would do 1 over the bubble and then times the derivative of the bubble itself. Well, if you allow the bubble to be this thing here, to be secant x plus tan x, then you're going to have here, you're going to have secant x plus tan x, and then here you're going to have secant x plus tan x, and then this thing here gets multiplied to the top. Basically you have found something that when you differentiate it, it will give you this. The point is that to integrate this thing here, it will be the natural log of the absolute value of this whole thing here. We've done this before, so you should know how to integrate this by now. This is just a reminder. So the trick in understanding how to integrate this is to realize that when you differentiate this, it will be its exact same self, but you times secant. So divide this to this, and then you have a derivative over the original thing. So if you make this to be your guess, see, blah blah blah, when you integrate this, it will then give you this thing here. So back to where we were before. We got to this stage here where we wanted to integrate from a to 9 of this thing here. So when you integrate this, it will then give you this thing here. Okay, so now remember, we now need to translate up now. Well, sorry, let me go back one step. So to integrate this, it will then give you this whole thing here. It will give you the absolute value of this whole thing here. Now bear in mind that a will always be in the positive realm, and the number 9 is always in the positive realm, so we can pretty much forget about this absolute sign. So ignore the absolute sign here. This whole thing here will then become this. So now we don't want the answer in terms of theta. We want it in terms of x. So now let's translate this. So to translate this this theta thing, we don't want the answer in terms of theta. We want it in terms of x. So we would go back to our original diagram. So this was from above. So go back to the original diagram. This here is our original diagram. Or secant of the angle would be this. So secant of the angle would be x over 3. So basically this thing here becomes this thing here. Well, tan of the angle, tan would be this thing here. So tan would be this divided by this. So tan theta would be this thing here divided by this thing here. So looking back at our diagram, we can translate this to this thing here, translate tan theta to this thing here. So now it's just a matter of us plugging the 9 into here. That would then give us 3. Plug the 9 into here. That would then give us this. And then plug the A into here. And then plug the A into here. That would then give us this. And then tidy this up. Tidy this up. That would then give you this here. And then so when we integrate it from A to 9, it will then give us this. Now hang on, let me go back one step. When we integrate it from A to 9, it will then give us this whole thing here. So now allow A to head towards 3 from the positive direction. So the minute you allow A to head towards 3 from the positive direction, you can actually say you're integrating, rather than from A to 9, you can say you're integrating from 3 to 9. So currently we're here. Now let A approach 3 from the right hand side. So really you're taking the limit as A tends to 3 from the right hand side. As A tends to 3 from the right hand side. So that will then so that's you taking the limit of this thing here. So now when you allow A to head towards 3 from the positive direction, this thing here will be 1. So that's 3 over 3 here. And then if you look at this here, as A tends to 3 from the right hand side, this thing here, A squared here, would be 9. 9 take away 9 would be 0. Square root of 0 would be 0. 0 over 3 is a legitimate answer. It doesn't break down. It's not like 3 over 0. This thing here breaks down. This doesn't break down. This is a legitimate answer. 3 over 0 does not break down. So it's a legitimate answer. So this whole thing here will then become this. So natural log of 1 is 0. So we can pretty much ignore this. So our overall answer will be this thing here. So hang on. Yeah. So this is your final answer. Okay.